Find the sum to n terms of the following Arithmetico-Geometric series. Okay, let us begin. So here we have an Arithmetico-Geometric series where the first term is 1, followed by the second term given by 3 over 2, added to 5 over 4 plus 7 over 8. Now, this particular series, this is not an arithmetic series because we don't have a common difference here. If we take the second term 3 over 2 and subtract the first term from it, the difference is not going to be the same as taking the third term and subtracting the second term from it. So this is not an arithmetic series. Also, this is not an geometric series because there is no common ratio here. Pick up any term and divide it by the previous term. That ratio does not remain fixed. So that means this particular series is neither an arithmetic series nor a geometric series. However, as the name suggests, it's an arithmetico-geometric series, which means that it is composed of an arithmetic sequence and a geometric sequence. So our goal will be to separate the arithmetic from the geometric. For this, we're going to rewrite the given series. We'll write the first term as 1 multiplied to 1, added to. Now we have 3 over 2 as the second term. We can rewrite it as 3 multiplied to 1 over 2. Coming to the second term, a third term, we have 5 over 4, but we're going to rewrite it as 5 multiplied to 1 over 2 squared, added to 7 over 8, so that's 7 multiplied to 1 over 2 cubed. So this keeps on continuing. Now here, we can see here, if we consider 1, 3, 5, 7, and so on, this particular sequence is going to be an arithmetic progression. That means they are in AP. And we can consider 1 from the first term, 1 over 2 from the second term, 1 over 2 squared from the third term, and 1 over 2 cubed from the fourth term. And this is going to continue. And together these terms are going to be in geometric progression. So they are in GP. Now that we have separated the arithmetic from the geometric, we can easily define its nth term. The nth term of the arithmetic progression is going to be 2n minus 1. And the nth term of the geometric sequence, that's going to be given by half raised to the power of whole raised to the power of n minus 1. Simply put, we have 1 over 2 raised to the power of n minus 1. Now, the benefit of finding out the nth term of the AP and the GP is going to help us find out the nth term of the Arithmetico-Geometric series. All we have to do is take the nth term of the arithmetic progression, which is 2n minus 1, and we're going to multiply to it the nth term of the geometric progression. So that's 1 over 2 raised to the power of n minus 1, or simply we can divide 2n minus 1 with 2 raised to the power of n minus 1. So this is going to be the nth term of the geometric series. We can verify that. So let's say we consider n to be equals to 4. That means we are trying to find out the fourth term of the series. According to the formula, so we have 2 times n minus 1. So replacing n with 4 gives us 2 times 8. So that's 8 minus 1 will be 7. Divided by 2 raised to the power of, we have n minus 1. So that's going to be 3. So that means we have 7 over 8 as the fourth term, which indeed matches with the fourth term of the Arithmetico-Geometric series. So now that we have the nth term, we are going to find out the sum to n term. So for this, we're going to assume that let Sn is going to represent the sum to n terms of the series. So we have 1 added to 3 over 2, added to 5 over 4, but we're going to rewrite it as 5 over 2 squared, plus 7 over 2 cubed. This keeps on continuing until we reach the last term of the series. So that's 2n minus 1 divided by 2 raised to the power of n minus 1. Now what we'll do, we'll also consider the second last term of the series. To find out the second last term, all we have to do is replace n with n minus 1 in the last term. When we do that, our second last term comes out to be 2n minus 3 divided by 2 raised to the power of n minus 2. Fine. Now, what we'll do next, we are going to consider the same sum Sn, but this time we're going to multiply throughout with the common ratio of the geometric progression. The common ratio of the geometric progression here comes out to be equals to 1/2. So what we'll do, we're going to multiply each terms of Sn with 1/2. So half multiplied to 1, that's going to give us 1/2. But we're going to write it below 3 over 2. Added to 3 over 2 multiplied to 1/2, so that comes out to be 3 over 2 squared. Added to the third term of Sn, that's 5 over 2 squared, multiplied to half give us 5 over 3 cubed, and we'll have the rest of the terms. Now coming to the second last term. Now the second last term, we have 2n minus 3 divided by 2 raised to the power of n minus 2. But when we multiply with 2, we're going to get 2 raised to the power of n minus 1 added to the last term of Sn. So that's 2n minus 1 divided by 2 raised to the power of n. Fine. Now what we'll do, we're going to perform a subtraction here. So we're going to subtract half of Sn from Sn. Now we have Sn minus 1 half of Sn. This is going to be equals to 1 added to, we have 3 over 2 minus 1 half. So that's going to give us 2 over 2 added to 5 over 2 squared minus 3 over 2 squared. So that gives us 2 over 2 squared added to 7 over 2 cube minus 5 over 3 cube. That says 2 cube actually. And that gives us 2 over 2 cube added to the remaining terms. Now we come to the second last term. So here we take the last terms of Sn and from here subtract the second last term of half Sn. That's going to give us 2 divided by 2 raised to the power of n minus 1 minus the last term of half Sn. So that's 2n minus 1 whole divided by 2 raised to the power of n. Okay, let us further simplify. Now Sn minus half of Sn, that's simply going to be 1 half of Sn. That will be equals to 1 added to, now we're going to consider the last term. So that's negative 2n minus 1 divided by 2 raised to the power of n. And if we check the second term, the sum from the second term all the way up to the second last term, this is a geometric series. Now it's a geometric series because it has a fixed common ratio. So here the common ratio R comes out to be equals to, so we'll take the second term which is 2 over 2 squared and divide it with the first term, that's 2 over 2, and that's going to give us a common ratio 1 half. We can check that out that it's going to stay fixed. If we take the third term and divide it by the second term, that's also going to give us 1 half. So here the first term, that's equals to 2 over 2, so we're going to consider it to be 1. Now the next task is to find out the total number of terms, because we know that the sum to n terms of a geometric series, that's given by the formula A multiplied to 1 minus the common ratio R raised to the power the total number of terms in the series divided by 1 minus the common ratio. So here we need to find out how many terms are there in a geometric series. So here there are a total of n minus 1 terms are present. So let's try to understand how come we have n minus 1 terms and not n terms. Now while performing the subtraction, we considered the second term all the way up to the last term of Sn, and in half Sn we consider the first term all the way up to the second last term of half Sn. So here consider Sn. So Sn here has got n number of terms, but here we have excluded 1. When we exclude 1 term from the total of n terms, that leaves us with n minus 1 terms. This is also happening in half of Sn. We have considered the first term all the way up to the second last term and we have excluded the last term, so it also is going to have n minus 1 terms. Now subtracting n minus 1 terms from another n minus 1 terms is going to leave us with n minus 1 term. Now we are ready to apply the general formula for finding out the sum of the given geometric series. So that comes out to be, we have the first term, that's 1, multiplied to 1 minus the common ratio, which is 1 half, raised to the power of the total number of terms. So here the total number of terms, that's n minus 1, divided by 1 minus the common ratio, that is 1 half. So here we have half Sn, that equals to 1 added to, so we have 1 divided by 1 minus 1 half, 1 minus 1 half, that's 1 half. So when it goes to the numerator, that simply becomes 2. We have 2 multiplied to 1 minus 1 over 2 raised to the power of n minus 1, minus we have 2n minus 1 divided by 2 raised to the power of n. So we have half Sn, that equals to 1 plus 2 minus 2 divided by 2 raised to the power of n minus 1 minus 2n minus 1 divided by 2 raised to the power of n. Now we're going to get rid of the coefficient of Sn, which is half, on the left hand side, because we need to find out the sum to n terms Sn. To get rid of this, all we have to do is multiply both sides with 2. So we have Sn equals to, so here 1 plus 2, that becomes 3. So 3 when multiplied to 2 becomes 6, minus we have 4 divided by 2 raised to the power of n minus 1, minus 2n minus 1 divided by 2 raised to the power of n, and to it we are going to multiply 2. This is going to give us 6 minus, now what is 4? That's 2 squared. Now 2 squared, when we take it to the denominator, that's going to give us 1 over 2 raised to the power of n minus 3. Minus, we have 2n minus 1. When we take this 2 to the denominator, that becomes 2 raised to the power of n minus 1. So this is going to be the sum to n terms. Furthermore, we can further simplify. We can take, let's keep the first term as it is. We're going to take negative 1 over 2 raised to the power of n minus 3 as the common factor. So that means we have this multiplied to 1 added to 2n minus 1 divided by 2 raised to the power of 2, which is now going to give us Sn equals to 6 minus 1 over 2 raised to the power of n minus 3. We multiply to 1 added to n over 2 minus 1 over 2 squared. And this is going to be the final sum. Thus, Sn equals to 6 minus 1 over 2 raised to the power of n minus 3 whole multiplied to 1 plus n over 2 minus 1 over 2 squared. That's going to be the sum to n terms of the given arithmetico-geometric series.